Hey everybody, welcome to video 7b1, and we're going to be talking about properties of parallelograms and especially other quadrilaterals that qualify as parallelograms but are also special kinds of parallelograms. And so we just want to kind of summarize all of these properties that we're going to be using in the next video where we're doing problems with them. Tomorrow in class we're going to be filling out kind of a chart of making sure that we have a summary of all of these different properties all at once. But let's go one by one first off here. We're going to need to write pretty small and pretty neat because there are quite a few properties, but I'm not going to rewrite them every single time. It's just that the parallelogram has a lot of really special things. So that's our first one. You can see the picture there in the right-hand column is already provided for you. We're just going to go ahead and add some markings to it. Parallelogram is spelled like this. And as we think about things that a parallelogram is, it's 5 different things, okay? So I'm going to put 5 little bullet points here. You might want to do the same to organize your work. And then we'll go one at a time. For the first one, it has, by definition, hence the name, 2 pairs of parallel sides. It also has those same pairs of parallel sides are also congruent sides. The next thing we need to know has to do with the angles, not the sides. And that is that opposite angles are congruent in a parallelogram. Now we're talking about consecutive angles, so the ones that are one right after another, if we're counting around the parallelogram either clockwise or counterclockwise. Consecutive angles are not congruent, but they do have a relationship. They are supplementary. And then the last type, or the last thing that we need to know about parallelograms is that has to do with their diagonals. And their diagonals bisect each other. So now that we have that written down in words, let's talk about what that's going to look like in a picture here. So if we just take the diagram that's given, we can mark the pairs of opposite sides as congruent. Put your tick marks on there. We can also mark the pairs of opposite sides, remember, parallel, and that's with our arrow symbols. So that's generally what we see when we see a parallelogram. I'm also going to add one more diagram kind of in the margin here if you guys can sketch another quick parallelogram with me so that we can talk about what this thing of diagonals being bisected means. There's one diagonal and there's another one. If the diagonals themselves are bisected, then that means that they are cut into equal pieces, each of them. Now notice these pieces are not the same length, all 4 of them, in any parallelogram, but they do bisect each other. Okay, so then one's midpoint is the same as the other one's midpoint. And that's going to come back into play when we talk about parallelograms on the coordinate plane. But for now, just know that they bisect each other. Next, we're going to go back and talk about the next type of special parallelogram, and that is a rhombus. And by definition, a rhombus is a parallelogram specifically with 4 congruent sides. So just know that when it talks about that it's a parallelogram, all 5 of these things, I'm just going to abbreviate parallelogram with the parallel symbol, and just remind you that all of the parallelogram properties still hold true for a rhombus, but in addition, it has some other things to add in, and that has to do with the diagonals. The diagonals not only bisect each other, but they are perpendicular. So you've got a right angle in the middle there. We'll draw that in a second. And the diagonals bisect not only each other, but the angles of the rhombus. So if we look over at the diagram for this one, we first are going to say that it's a parallelogram with all 4 sides the same. We can put in the parallel markings if you want, but it's going to start to get pretty busy, so I'm going to leave them off of this one. But if we draw in the diagonals, we know that the diagonals themselves are perpendicular, so essentially it creates 4 right triangles with those diagonals. And we also know that the diagonals, because it's a parallelogram, still bisect each other. So keep in mind that's what the rhombus would look like as far as the sides go, what the diagonals do. Another quick sketch of a rhombus right here in the margin, if you will. And let's talk about what happens when the diagonals, what they do to the angles themselves. So because the diagonals bisect the angles, we can say these 2 sides and these 2 sides all have angles that are the same. These 2 sides of this diagonal and the angles on either side of that diagonal also have congruent angles. So if you will, you can think about a rhombus can be folded, meaning it's got symmetry, 2 different directions. That's how I always think of it. If I can fold it onto itself, then I can remember what pieces are the same. All right, moving on to our next type of special parallelogram, and that is not a rhombus, but a rectangle. You guys have probably known this definition for a while, like since elementary school, but we're going to put it in more specific terms here. A rectangle is still a type of parallelogram. And so again, we'll highlight that all of those properties of the parallelogram still hold true. Notice I did not draw an angle right to the rhombus. Okay, I drew an angle, or an arrow, excuse me. I did not draw an arrow to the rhombus. I drew an arrow back to all of the parallelogram properties that we wrote down. So just because it's a rectangle doesn't mean it's a rhombus. But because it's a rectangle, we can assume that it's a parallelogram, so it has all the properties of a parallelogram. And a rectangle is a parallelogram that has not all the sides the same, but it has 4 congruent angles. And specifically, since you've got a 360-degree total, as we know from our previous video, and you're dividing in that into 4 equal angles, that means all of those angles are 90 degrees. Okay? In addition to knowing that about a rectangle, again, dealing with specific cases with the diagonals, if it is a rectangle, the diagonals have to be congruent. So let's look at the picture. As we draw through here, we've got corner, 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 and corner of 90 degrees. We've got diagonals drawn in. And because it's a parallelogram, we know it's going to bisect itself, going both directions. But because it's a rectangle, we know that actually these are all the same length because both of the diagonals are the same length, so all the halves of the diagonal have to also be the same length. So that's what we're looking at there, just additional things in addition to the fact that the opposite sides are congruent and parallel and that the diagonals bisect each other, opposite angles are congruent, consecutive angles are supplementary. Again, everything that a parallelogram is, a rectangle is as well, okay? Just a couple of extras. Then the very last thing is what we call our perfect parallelogram, and that is our magic square. And of course, you know what a square is, but as in terms of all of the properties that a square has, remember that a square is a parallelogram still. I'm not going to draw another arrow because I think it'll get really messy here, but remember, a parallelogram has all the properties of that first box, but that is both, in this case, a rhombus and a square, or excuse me, a rectangle. So it's kind of like if a rhombus and a rectangle got together and had a kid genetically, if you can think of that, then that's what a square would be. So let's look at the diagram there. We know it's got all four corners that are the same like a rectangle does, but the diagonals are going to be, because it's a rhombus, the diagonals are not only going to be congruent because it's a rectangle, but because it's a rhombus, they're going to be perpendicular. So keep in mind that means all of these four diagonal half pieces are the same, and if it is a 90-degree angle in the middle there, I hope that you can see that what's been created is basically four different 45, 45, 90 triangles. Also, you should know that as far as what the diagonals do, remember, to the angles themselves, because it's a rhombus, we can also say that all of these pieces are the same as well. And so each one of those red marked angles there, if it's a square, is going to also be 45 degrees. So that just kind of emphasizes the whole 45, 45, 90 piece as well. So I know that was a lot of properties to throw at you guys all at once. I hope that you were able to follow that. I hope that some of that was review, but we're going to just kind of be summarizing all of that in the lesson tomorrow. So have a great night.